Hello students, welcome to my YouTube channel. Today in this video we are going to see about the application of junction diode. In the previous video of semiconductor devices we have seen the working of PN junction diode in forward biasing and reverse biasing. So let's start the video. So application of PN junction diode as a rectifier. This is our topic. So first, what is a rectifier? So rectifier is a device which converts AC into DC. So basically rectifier is a device. Rectifier, it is a device. It is a device which converts AC, alternating current, AC into DC, direct current. Now basically there are two types of rectifier. Rectifier, we will study two types of rectifier. Rectifier first is known as half wave rectifier. Half wave rectifier, and second one is the full wave rectifier. One is the half wave rectifier, other is the full wave rectifier. And from the name itself we can predict the nature of the working of the rectifier. Half wave rectifier, it will convert the half cycle of input AC into DC, and full wave rectifier, it will complete the full wave. Half wave rectifier, it will converts half cycle of input AC into DC, and the full wave rectifier, it will convert full cycle, complete cycle, converts full cycle, means complete cycle, full cycle of input AC into DC. So basically in input we will provide the AC, and with the help of the rectifier we will convert into DC. The name of the device which converts AC into DC is rectifier, and basically this rectifier uses the PN junction diode to convert AC into DC. So one by one we will study about the half wave rectifier and full wave rectifier in detail. So let's start with the half wave rectifier. So first we are going to start half wave rectifier. Half wave rectifier. So what is a half wave rectifier? Just I've explained. It is a device which converts half of the input AC into DC. And what is the working principle? The working principle of both the half wave rectifier and both the and full wave rectifier is based on the principle that PN junction diode conducts only when it is forward bias. So we can write down about the half wave rectifier. A half wave rectifier, a half wave rectifier converts half of the input AC, or half cycle of the input AC into DC. Its working principle is, it works on the principle that on the principle that a diode conducts only when it is forward biased. So this is the working principle of rectifier. Whether it is a half wave rectifier or full wave rectifier, a diode will conduct only when it is forward biased. This is the working principle. Next we will see about the circuit diagram. So next is the circuit diagram of half wave rectifier. Circuit diagram. So let's start with the circuit diagram. First we have a transformer. This is the input side. We have one diode also. This is the diode. And this is the circuit diagram. Just wait for a minute. Now we will start. So this is basically your transformer part. It's a step down transformer. With the help of this step down transformer, the voltage is step down. This is our transformer. Here is one diode. Diode is connected. This is your P type, and here is your N type. This is your diode. We have one resistor across which we will get the output, and basically this part is input AC applied. Here input AC, IP AC is connected like this. We can connect, and this part is basically your transformer. You can see it there. A step down transformer it is. Now we can mark the terminals. This is your diode D. This is your resistance RL, load resistance we can say. This is your load resistance, and here we will get the output across this resistor. Output, it will be in the form of DC, and this is your diode D. We can mark the terminals. This terminal is A, this terminal is B, this terminal is X, this terminal is Y, this terminal we can mark as AB. So this is the circuit diagram of half wave rectifier, and this transformer is basically your step down transformer. Step down transformer. This is the core of the transformer basically. This is the core of the transformer. So this is the complete circuit diagram of the half wave rectifier. Now we will see about the working how it works. So basically, now we will see about the working of the half wave rectifier. Now working, we will see. So number one, when positive cycle of input AC is applied, when positive cycle of input AC is applied, input AC is applied. Now we will mark the polarity. Now suppose positive cycle of this input AC is applied. This terminal will be positive, this terminal will be negative. Now similarly the transformer terminals, this will be positive, this will be negative. Similarly the secondary winding, this will be positive and this will be negative. You can easily see. So now we can say the diode D is connected with the positive terminal P type, and this N type it is connected with negative terminal. This is the P type semiconductor and this is N type semiconductor. So diode is forward biased and we will get the current across load resistor which will flow from X to Y. So when positive cycle of input AC is applied, terminal A is positive basically. Terminal I have already marked. Terminal A is positive with respect to B. With respect to B, and thus we can say the diode, thus diode D is forward bias. Diode D is forward bias. Why diode D is forward bias? Because its P type it is connected with the positive terminal, that is terminal A, and its N type it is connected with the negative terminal, that is terminal B. That's why diode D is forward biased, and when it is forward bias it will conduct. Thus the diode D is forward bias and it will conduct, and it will conduct, and we will get the output, and we get the output OP, output across load resistance, across load resistance RL, load resistance RL. Flow direction is the direction of flow of current is flow direction is the direction of flow of current is direction, the flow direction of current is from X to Y. You can see it there. The direction of current when it is forward bias, the current will flow from X to Y. The current will flow like this, okay, to the load resistance. Suppose the current is IL and the resistance is RL, then output voltage V naught, it will be basically IL into RL. This is the output voltage. Now we will see about the negative half cycle. Now let's see about the negative half cycle. So when, now number point 2, when negative half cycle, when negative half cycle of input AC is applied, input AC is applied. Now we will see what will happen. If the negative half cycle, now direction will reverse, this direction minus, now this is plus. So terminal A will become now negative and terminal B will now become positive. Now this terminal A will become negative and terminal B will become positive. If the negative half cycle of input AC is applied, then terminal A is negative now, negative, and terminal B is positive. Terminal B is positive, and hence due to this, because the diode is connected, and thus we can say, and thus diode D is reversed biased. And we know if the reverse voltage is less than reverse breakdown voltage, then the diode will not conduct. Reverse biased and it will not conduct. The diode will not conduct, it will not conduct, and we will not get similarly, and we will not get any output, any output across load resistance. So here the output voltage here in this case it will be equal to 0, but in case of input cycle the output voltage it will be equal to IL into RL. So this is the working during the positive cycle and the negative cycle. Similarly these two cycles will continue and we will get the current only. So basically this process will continue. What will happen? Positive cycle, negative cycle, one by one when we will apply. So what will happen? The cycle continues, and we get output, in direction from x to y, means our current will flow from x to y in a fixed direction only in positive half cycle of input AC applied. Input AC. That's why the name is half wave rectifier. So basically we will get the output only when we are connecting the input AC, positive half cycle of the input AC. So this is the working of the half wave rectifier. Now we will see the waveform. The waveform of input and output we will see one by one. So this is the waveform now. So this is the waveform of half wave rectifier for input and output. Let me draw the waveform. Let me choose the axis first. This is the x-axis. Now we can draw two lines. There's no use of this. Now we will apply, first we will see the input AC. Now let me draw the input AC. This is your input AC. Positive cycle, then negative cycle, then positive cycle, then negative cycle. This is the input AC. And we will get the output only when this is the positive cycle of input AC. This is the negative cycle, positive cycle, negative cycle. Like this it will go on. This is your input AC. Now we will see the output. This is the output DC. We will get the output only when it is forward bias, positive half cycle. Output, and similarly we will get the output in the next case also. Like this we will get. So this is the output. OP output. It will be DC. It is not perfectly DC, but it is basically in only positive cycle. In one direction we will get the current. The output voltage is given by, the output voltage is basically, it is equal to V naught it will be basically V naught V by R. No. Yes, it will be basically I naught. If suppose the load current is IL or I naught, Maximum value I'm taking I naught divided by pi into RL. This is the average value of output voltage. So this is the working of half wave rectifier. Now we will see about the full wave rectifier. So full wave rectifier converts the full cycle of input AC into DC. That is the basic difference between half wave rectifier and full wave rectifier. So now we will study about the full wave rectifier. So now we will see about the full wave rectifier. So basically you can write down a full wave rectifier will convert full cycle of input AC into DC, and its working principle is same. It conducts only when, or a diode conducts only when it is forward bias. So directly I am coming with a circuit diagram. Circuit diagram we will see first. So this is the circuit diagram we are going to draw. This is the input side. Input side, two diodes are connected, diode D1, diode D2, then we have one connection here. Let me complete the diagram first, then I will explain each and everything. Okay, now we have this diode, two diodes are there. Let me draw the diodes. This is your diode D1, you can see it there, diode D1. We have two diodes, diode D2, P type and N type. P, this is your N, this is two diodes D1 and D2, and we have this transformer winding, primary and secondary. It will be not drawn perfectly. So this is your transformer winding here. Let me draw the transformer. Primary winding, this is your primary winding, and this is your secondary winding, and we have this core. This is your core, the transformer. You can see it there. Now we are, it is basically center tapped full wave rectifier. So its center will be tapped. Let me draw with the another. It is a center tapped full wave rectifier. Directly here we can connect. Okay, so this is your center tapped. Basically bridge rectifier is also there, but we are going to see about the center tapped full wave rectifier, and this is your load resistance RL. The terminals we can mark now. This terminal we can mark X, and this terminal we can mark Y or XY. This terminal we can mark as terminal A, and this terminal we can mark terminal B. Here is the input AC. This side input AC is applied. Let me draw the input AC. Here input AC is applied. You can see it there. Here input AC is there, and these are the terminals of transformer. This is a step down transformer. You can see it there. This is a transformer. So basically this is the diagram of full wave rectifier. Basically it is a center tapped full wave rectifier. It is basically center tapped full wave rectifier circuit diagram. Full wave rectifier. Now we will see the working. Directly I will explain the working. Okay. The working is basically very simple. Two diodes are there. This diode I'm taking D1. This diode as D1. Let me choose these two diodes. These two diodes are D1. This diode is D1 and this diode is D2. So this is the circuit diagram. Now we will see the working of this. It's not working now. So now we will see about the working of this full wave rectifier. Okay. Working. So point by point you can write down. So the first point is when positive cycle of input AC is applied. Now in input IP we are applying the positive half cycle. When we are applying the positive half cycle of input AC, positive half cycle, then what will become? The terminal A will become positive. Look here, if you are applying the positive half cycle, this terminal will become positive, this terminal will become negative. Similarly, the terminal A will become positive and terminal B will become negative, because now diode D1 is connected with positive terminal. So in this case, diode D1 will be forward biased. Diode D1 will be forward biased, and D2 is connected with terminal B, which is negative. So diode D2 is reverse biased. It's very simple. Once you will mark the polarity, you can easily identify which is forward bias and which is reverse bias. Since D1 is forward bias, so it will conduct, and D2 is reverse bias, so it will not conduct. So does not conduct. But still one diode is conducting. So what will happen? This diode will conduct and you will get the current in this direction from Y, and it will go like this. You can see it there. And the current here you are getting, output current you are getting in the load resistors, output current, because D1 is conducting, so output current you will get from Y to X, Y to X in load resistance RL. This is the working of the diode when we are applying the positive half cycle. Now when we are applying, input is now negative half cycle. Negative half cycle of input AC is applied. Negative half cycle. Then what will happen? When we are applying negative half cycle, then this terminal, just look at the terminals. This terminal will become negative and this terminal will become positive. Similarly, the terminal A will become negative, terminal B will become positive. Clearly you can see the diode D1 is now connected with the negative terminal. So what will happen? The diode D1 will be reverse biased now. The diode D1 is reverse biased now, and D2 is now forward bias now because it is connected with the positive terminal. D2 is forward bias. So what will happen? Since diode D1 is reverse bias, so it will not conduct, but diode D2 is forward bias, so it will conduct, and we will get the current again due to this conduction of diode D2. So the diode D2 will conduct from positive to negative. It will go the current like this in load resistance from Y to X. Again we will get the output current we will get from Y to X in the same direction in RL. So we have seen in both the cycle, positive half cycle and negative half cycle, the direction of current in load resistance is fixed now. It's have become now unidirectional. Similarly, the process will continue and we will get uh, the output in every cycle of input AC and output input AC in a fixed direction. Now we will get the current from Y to X. So this is the working of the full wave rectifier. Okay, so this process basically will continue. So process will continue, process will continue, and we will get the current, continue, and we will get the current, can output current basically for both cycle of input AC. In both the cycles, both cycle of input AC. And since the current is unidirectional, in only one direction it is flowing, that's why it is direct current. Now we will see the waveform now. So this is the working of the half wave rectifier. Now we will see the waveform, input waveform and output waveform. So we are going to draw the waveform now. Waveform. Input and output waveform. First let me draw the input AC. This is your input AC. And output, now let me draw the output. For each cycle we are getting the output. This is the output. You can see it there. You can see it there. So basically this is giving your input AC and this is your output DC. Voltage and current waveform we can draw. This is your positive cycle. In positive cycle, diode D1 is conducting and you are getting the current. In negative half cycle, diode D2 is conducting and we are getting the output current. Similarly, in positive half cycle, diode D1 is conducting. In negative half cycle, diode D2 is conducting. So this is the waveform of positive half cycle and negative half cycle, or the input AC and output DC. We have seen this waveform. Okay, this is the waveform. But basically you will see that now we will see the what will be the output voltage in this case. The output voltage is basically in this case is output voltage V naught is basically it is equal to 2 into I naught by pi into load resistance, that is RL, where I naught is the peak value of output current, that is secondary current, transformer current, peak value of output current, and RL is the load resistance. RL is the load resistance. This value we can easily calculate, load resistance. Okay, this is the simple formula of output voltage. V naught is equal to 2 I naught by pi into RL. Basically we can calculate the average value, okay, during the positive half cycle. And what is the frequency? We have seen if the input frequency, if the input frequency is f, frequency is f, then output frequency, because the same cycle is repeated in half of the time, you can see in the output DC waveform and input AC waveform, you can see This is repeating in half cycle of, look, if the total time period is t, then its time period will be just t by 2. In half of the time period, it is repeating its waveform. So output frequency, it will be equal to 2f in case of half full wave rectifier. In case of half wave rectifier, the output and input frequency will be same. Now you can easily see that this waveform is not, the output waveform is not completely DC. The ripples are present there. So basically how we can remove the ripples? The ripples in output voltage, the ripples in output voltage can be minimized, can be minimized using a capacitive filter. We can use a filter to remove the ripples in the output DC using a capacitive filters. Basically capacitive filter we need to use, capacitive filter we can use to remove the ripples in the output waveform. So this is the way we can use. So here we can place one rectifier. Let me draw the diagram. Here we can place the rectifier. This part is your rectifier. Okay, and now we can connect the terminals. This is your input side. Here we will apply the input. Here is the output from the rectifier. Okay, here is the output from the rectifier. You can see it there. And now we can connect the filters here. One capacitor we can connect here. One capacitor is connected here. And here is the load resistance. Here is the load resistance. So from here we can connect one capacitor. This is your capacitor having capacitance C, and this is your load resistance RL, and from here we will get the output, actual output DC. Ripples, now it will be removed. This is your rectifier, either half wave or full wave rectifier, and this is your input AC. Here is your input AC. So the ripples in the output can be minimized by using a capacitive filter here. So that's all from the today's video. Today we have seen about the working of the half wave rectifier and full wave rectifier. Thank you everyone for watching. In the next video we will study about the optoelectronic devices, more about the application of the diodes.